Hello everyone, welcome to today's session with Hoy Lam. Hoy is gonna be presenting on Android machine learning today. Hoy leads the Android machine learning developer relations team at Google. I'm sure this session is going to be very helpful for all the Android developers out there who are looking to integrate machine learning in their Android applications. So without any further ado, I'll just hand it over to Hoy. Hoy, why don't you just take it away?
Hey, sounds good. I hope that everyone is doing okay at home. I'm certainly enjoying a little bit of a break at the moment in London on a Saturday, but I'm really glad to be here to be talking to all of you. Yeah, as I said, I lead the Android machine learning developer relations team, and today I really want to go through a lot of the changes and product release that we have done in the first half of 2020, and also I've updated this deck so that it's less about the different products that Google is providing, but more about the developer journey that you may go through if you build for on-device machine learning. So let's kick it off. The first question a lot of you might ask is, hey, why do we have machine learning? What is it useful for? And let's take an example. So traditionally, if we talk about activity detection, let's say, walking, then you might say, well, we can just look at one feature of walking, which is the speed. And if it is more than a certain or less than a certain kind of speed, then it is walking. If it's running, then we kind of add another if and else statement using that just one feature. And then finally, if we have biking, then we can add yet another, if else statement and say, hey, if it is faster than running, then it must be biking. But what if we add another activity like golf? How would that work? In traditional programming, what we have is essentially a bunch of rules and data as input, and then we output this as an answer. In machine learning, what we try to do is to give the computer both the answer as well as the data, and it out pops the rule. And this rule might then, when you're during runtime, be feed back into the traditional programming mode and combine with the data they detect to then give you the answer. So in the training, you might go through what is showing off in the green box in this particular slide, where answer and data goes through and the rule pops out. And then you end up with something like this. And this will make it really easy to extend to other activities. And also, it would not be sensitive to just the one feature of the individual. So let's say, if the individual is really fast in running, then, maybe by taking into account of all the gyroscope and the accelerometer kind of reading, then we'll be making less mistake that particular person is actually biking. So there is a lot more to the usage of machine learning in some of these activities or things that we might want to do. And then the second thing, after we decided that machine learning is the correct thing to do, the second question that you might ask is, why do we want to do it on device? In particular for this session, why should we do it on an Android device? It's because of three things in my view. So the first thing is privacy. The data stays on your user's device. Second is it works offline. So it works even in the London Underground here in London. And third is low latency. There is no round trip to your server. So you can provide a live experience to your machine learning algorithm and actually change the user's experience. And this to me is actually the most striking thing about on-device machine learning is that you can actually create new user experiences. So in the rest of the talk, I'm going to go through the 4 different steps that you might go about creating machine learning, and in particular on-device machine learning, from designing for machine learning to finding a model, maybe pre-made by Google or someone else, maybe build a model if the model that you find doesn't quite fit your need. And then finally, implementing it, actually adding the model to your Android application. So first thing, design. We launched the People Plus AI Guidebook at I/O 2019, and this is the best practice that Google have learned from basically creating its own machine learning applications. And one of the first topic that I want to kind of maybe highlight and give a little bit of example about is the user's need and define success. And some of these might sound quite obvious, but you'll be surprised kind of how many of us kind of fall into those kind of pitfalls the first time we approach on-device machine learning. So the most common problem that I get when I talk to a developer is, hey, how do I add machine learning to our app? Hey, my manager asked me to do it. My boss asked me to do it. How do we do this? What we suggest is actually let's cross out that particular question. But instead, we focus on the user's problem. So how might we solve a certain user problem? And then we can ask, can this problem be solved in a unique manner using machine learning? And where we want to get to is where the star is, where the user impact, hopefully positive, is very high. And also the solution that requires to solve that particular problem is unique to machine learning. And in those cases, we can add a lot of value instead of being really frivolous with the usage of machine learning. Another thing that I often encounter when I talk to developer is that the thinking in terms of how we approach machine learning is often one of automation. So previously, step number 5 is done by the user. Let's automate it and let's take out step number 5 and take the human out of the loop. That is perfectly possible, and it is maybe a valid thing to do for particular use cases. But I would also encourage developer to do another thing, which is to think about another way of implementing machine learning that we call augmentation. So in this particular case, what we do is we say, hey, can we add machine learning to the user flow to give the user superpower and help the user accomplish the task? So for example, let's say if you're a bank and you need to upload a letter as an image to help the user prove who they are, your machine learning algorithm could do something like, can I read the entire letter? Is the picture focused? Some of those things machine learning can help you do, and basically make the outcome better without taking the human out, and instead enhancing the user in the process. So now that we've gone through a little bit of design, and let's say you have identified a user problem that you can solve with machine learning, and what's the next step? What's the next step that you should do? So the easiest thing to do with machine learning is to find the exact model that you need, or something similar to what you want. And here we have 3 different solutions: MLKit, the Android platform, and also TensorFlow Hub. Let me go through kind of each one of those. So first, I'm sure MLKit is the ready-made library that you can use just like any other SDK without any machine learning expertise. And it's just built for cross-platform needs. I know that this is an Android developer event, but it also works on iOS. And then a lot of the API depends on the TensorFlow Lite library. And since June, what we have done is we have actually separated out the on-device machine learning APIs from Firebase. So you no longer need to apply for a Firebase account before you can use it. So right now, if you want to use face detection, this is the one line that you need in the build.gradle file, and you can start coding. There are many different functionality available. I won't go through all of them on this slide, but instead I will choose 3 of them to highlight and to basically tell you what is unique about the MLKit offering. So I'll go through smart replies, translate, and also object detection and tracking. So the first thing is smart replies. It provides answers to so many live questions, like in this case, should you take a job at Google? And the really special thing about this API is that we have done a lot of testing with our partners. And one of the requirements that we find is actually for some topics, you just want to back off. So for some politically sensitive topics, or for other topics that may be controversial or maybe related to things like self-harm, etc., the algorithm is designed so that it will actually not give you and not provide any answer at all to your user. Things like politics or religion. So that's smart replies. Next is on-device translation. First of all, it supports 59 different languages, and also the model is the same model that we use for the Google Translate app. It runs completely on device, so your conversation is not transmitted to Google, and it is offered at no cost. Finally, object detection and tracking. In this example, our partner IKEA created this app, enabling the user to pick out exactly what they want by just basically pointing their phone at the particular object, check the price and stock level. So how does this particular app work? So here's the flow for the app. First, it detects the object. Second, and this is optional, there's a filter for the different categories, from home goods to colored plants, etc. You could switch on the different filters, etc. And then finally, you can call on Google Cloud or other kinds of cloud services in order to get back the inventory. And this is maybe a great example to discuss a little bit about the difference between on-device and machine learning, and also kind of cloud-based machine learning. So for the on-device machine learning, you want to concentrate on the live experience for the user. So as the user points at the particular plant or the sofa that they want to buy, you want the box to stay with that object. And that is only really possible with on-device machine learning due to network latency. But then on the other hand, you have perhaps, let's say, a very large inventory of products, and also maybe those products change, hour by hour, depending on their availability. Then you want perhaps, in the cloud services, basically updating their model pretty much on an ongoing basis without shipping, let's say, 100 megabyte model to each of your user. So that may be one of the ways that you can use both on device as well as cloud-based machine learning, and using them together to build a particular use case. And for more information, you can go to this link, g.co/mlkit. Next, the Android platform. So I'm sure that a lot of you have watched I/O last year, where I demonstrated this particular demo on stage, where I said in my native Cantonese, I'm from Hong Kong, to say that I'm really happy to be here talking to all of you in Cantonese. And the machine was able to, or my phone was able to read it back to me. And just to kind of highlight that this is not something that's new. This is something that we have introduced a long time ago. In fact, the text-to-speech functionality we launched back in 2009, so that's more than 10 years ago. And then for speech recognition, we launched it in API level 8, and it supports a very wide range of languages. And the team have been improving those voice model on an ongoing basis. So it's really worth checking out if you have a use case where you want to dictate the user's speech, and or maybe kind of reading it back. And for more, you can watch the video from last year's Google I/O What's New in Android Machine Learning, where I go through the demo as well as a lot more detail in the code. But before we go on this particular topic, I just want to highlight one thing, which is the parameters you can set as you create the speaking intent for the language. So we, like I said, I'm from Hong Kong, and the language of Cantonese is only really spoken by around 7 million Hong Kongers in Hong Kong, and maybe a bit of Canton or the south of China. So this is not a huge kind of language, but yet it is supported. So I'm sure that a lot of the language that you want to target could potentially be already on our support list. So if you have got those kind of use cases here, then please do try it out and let me know how you get on. Next, TensorFlow Hub. So TensorFlow Hub is a very large repository of TensorFlow model from both Google as well as the wider research community. And for mobile developer, the section that we're really interested in is this, the TF Lite section. So with TensorFlow Lite, and you probably know this already, it is both a model format as well as a framework for running a machine learning model on mobile and Internet of Things devices. And the graphs for TF Lite is optimized to run on these form factors. So on this website, on TensorFlow Hub, once you click on it, you'll see a complete list of model that is compatible on the screen. But I'll typically use the search box at the top to basically search for the model that I really want. As you can see, there are various different models from pitch extraction to image transfer to, of course, the object detection that we know about. So all of those are available on this website. Please go and search for it. And at this point, I want to maybe highlight a couple of models that have been recently released by both Google Research as well as the external research community. So at CVPR a couple of weeks ago, this is one of the industry-leading vision conference. We announced a couple of large-scale classifier that is now available on TF Hub. So the US supermarket goods, 100,000 different classes of goods, wine labels, 400,000 different wine labels you can find. So this is something that previously was only possible with a cloud-based model simply because the model itself is so large. And some of this remains to be the case. So although it is not multi-hundred megabyte large, for the US supermarket goods, I think it's about 30, 40 megabytes. For the wine label, it's about 100, 140 megabytes kind of large. But it is at the very least possible. So if you're interested in these kind of very large scale classifier, not just classifying one or two classes, not just hot dog, but instead, 100,000 or 400,000 different classes, then please do check out both the model on TF Hub as well as the research paper. Another thing that I'm really excited about is the third-party contribution from the wider research community. So here we have two different models, one CropNet for detecting diseases in cassava, and then the other one, AgriPredict, for detecting some diseases in maize, soya, cabbage, as well as tomatoes. So those are really exciting kind of new improvement that you can find on the TF Hub website. So these are the places if you want to find a model, or maybe just kind of want to use those models as part of an SDK. You have MLKit that offer a very wide range of different functionality. With the Android platform, we have both speech recognition as well as voice to text to voice. And then on TensorFlow, we have TensorFlow Hub, where you can go and search for different models that you might like. So next, what if the model doesn't quite exist, or the model existing doesn't quite fit what you want? What can you do to train for the most common use cases? So here you have two choices. One is Firebase ML, the other one is TensorFlow. So first, with Firebase, they offer a number of online services, including TensorFlow model hosting. But the one that we're going to talk about is the AutoML functionality. So the flow is like this, where if you have different categories of objects that you want to classify, you could just upload a bunch of photos to Firebase ML, and then just use Firebase ML to work out the model for you, and the output will be a TensorFlow Lite model. And the screen looks something like this. So you import the various cases of flower in this example and give it labels. And then you choose what kind of model characteristics you want. Do you want a smaller model or a bigger model? And what kind of accuracy and latency do you want? And then you can choose the amount of computing power that you want to invest in this endeavor. And then finally, you will basically just get a model that is in the TF-Lite format, and you can import it into your Android project and run it. So that's the Firebase ML offering. Next, I want to introduce is the TensorFlow Lite Model Maker. This is something that we launched back in Q4 of last year, and it deals with some of the very common use cases in machine learning today. So the first one is the first thing I want to highlight is actually that there's a whole bunch of different tutorials that you can go through on the TensorFlow website, and the URL is here. And then the one that I'm going to focus on is the model maker, and it at the moment contains two different common model types that you might want. So the first one is of course image classification, and there are very easy ways for you to kind of run this if you just kind of click on the run on Google Colab. In addition, the other thing that I want to highlight is that it's also very easy to change the base model that you're using for this particular task. So let me take a step back. In a lot of the image classifier, what we do is we start off with a base model, and then we say, hey, we don't want to tell the difference between strawberries and dogs anymore, but instead we want to tell the difference between apples and oranges. So what you do is you basically add a couple of layers or change a couple of layers in the existing model, so that the last couple of layers in terms of the classifier changes to adapt to your new use case. And you retain a lot of the knowledge within the model that tells the difference between a curve or a straight line or different objects, etc. So in those cases, you reduce the amount of processing time that you need to train a new model because you're not training from scratch. But at the same time, you get the custom classification that you want. And in this case, you can very easily, using the model maker, you can very easily select different base models, things like, and I'm sure a lot of you have heard, things like MobileNet or EfficientNet, very popular models that are used in the mobile context. You can just say, hey, let's use the EfficientNet as a base model, or let's use the MobileNet as a base model. It's one or two lines. It's very easy to use. If you compare that to kind of the previously, you need to kind of write out all this Python code. So that's the model maker with image classification. A second use case that we have is with text classification, and you can find them both on the TensorFlow website. Going forward, there will be more use cases that will be coming, so please stay tuned. So just to sum up, there are two solutions here. If the model that you found earlier is not quite what you need, you can use the Firebase ML solution to train your own custom image classifier, or you can use the TensorFlow Lite or the TensorFlow Model Maker for your need. So once you have got the model itself, the next step is integrating the model into your Android app. And here we have three different solutions for you. A lot of these are new, so I'm super excited to basically talk about these. So there are three different ways that you could integrate or two different ways to integrate the Android model. And then also I want to talk a little bit about CameraX, since a lot of the use case with machine learning is to do with vision. So I just really want to kind of go through what the latest kind of offering that you can find with CameraX. So the first one is that from Android Studio 4.1 alpha and now beta, we have now introduced the machine learning model binding that supports the TensorFlow Lite. So let's kick it off with a story. So back in 2018, when I attended DroidCon Berlin, I created this program that do Hoi or not. So I created this model that tell me whether someone I'm seeing is Hoi or not. And in this case, as you can see, I'm 83% Hoi. We actually get better results with developers on the ground. So when I actually went through the presentation, they were actually over 90% Hoi. So decide what you will about what that means. But that's not the important story. What is important is the code that got me there. So the code actually to run the model looks something like this. And why is it so complicated is because you can't actually run the model without converting the bitmap into the correct format for in byte array before you can run this or byte buffer. And even when you kind of do a lot of this, quite often the first thing that you see are errors like this. It's like, hey, the file is not kind of quite right, and also the input dimension is incorrect, or maybe the different types are incorrect. And a lot of these stem from the fact that when you run the model, it actually looks something like this, where you had bitmap, you had string to begin with, but then you convert everything into byte array, and you don't quite know whether it is kind of done correctly. And some of the model, and I'm sure like a lot of you know, that there are kind of float model as well as unsigned integer models. So in order to save space, instead of using a 32-bit float, some model uses a trick that will convert each of the weight in the model from float to a unsigned integer, which is 8-bit. But if you have done that, then the byte array conversion is different. Both on the input as well as the output side, and it is quite difficult. At least when I was starting, it's really difficult for me to do it. And even after I've done it a couple of times, I still run into some problem occasionally. And because a lot of these are very obscure kind of calculations, it's not always easy to find out where the bug is. So the TensorFlow team and the Android developer team got together and say, hey, what can we do about this? So the first thing that we decided to do was to add metadata to the TensorFlow Lite model. So previously, all we have in the TensorFlow Lite file is just the dimension of the array for both input and output. We have no idea what that array actually is. Is it just a bunch of number, or is it like a bitmap? And then the second thing is, hey, wouldn't it be great if we have an import visit to do this? And it will just generate a wrapper, and there will be code that you can just copy and paste to do this. So these are the actual wireframe that we use in the proposal. And with Android Studio 4.1 beta, these become a reality. So this is how you use it. So in your in the module that you want to implement the particular model, you can just right-click on the module itself and just go New, Other, TensorFlow Lite Model. And then you will see a dialog box like this, where you locate the model, and then you basically take the different boxes to basically include the dependencies that you need. If you want the GPU acceleration, you can also take the second box so that you can import those already or add those dependencies to your project. And then finally, you will see a screen like this, and the exciting thing for me is basically the bits at the bottom, where you can just copy and paste the code snippet that you can just use, and immediately the model will just function as you expect. So to check it out, just go to the Android Studio 4.1 beta at this address and download the Android Studio 4.1 today. Next, MLKit. So there are, as I said, there are many offerings in MLKit, but two of the offerings we had, both image labeling as well as object tracking and object detection and tracking. Since launch, we have had a lot of developers asking us, hey, can I just plug my own model in, and you basically manage the pipeline and all of that for me, or the tracking? So the new version that we have launched in June, the new standalone MLKit, actually has that, and it will and it does now accept custom models. And you can see both those working here. Some people did ask us, hey, which one should I use? Because they both look very similar. It's like they're both have a image classifier as an import. So what we suggest is if you have different objects that are lined up, but the user is only really interested in one of those objects instead of all of it, then we would suggest that you use the object detection and tracking. So if the object only takes up part of the picture. On the other hand, if you are looking at, let's say, a scene or a landmark in this case, then image classification or MLKit image labeling will be a much better way to do this, because the entire screen is essentially the object that you want to that you try to detect. And one thing to highlight is it is not just about the landmark, but it could also be a scene. So, for example, if you want to detect the difference between a forest or a beach, then you could actually use image classification / labeling to do that. So that's the new MLKit offering. Finally, camera. So I'm sure that a lot of you have done this. You were kind of coding away, and in a lot of the machine learning sample that you will find on the web, you find that they're using Camera 1 code. And I have to put my hand up. When I first perform machine learning, this is also what I did. And then if you're using Android Studio, it will remind you that, hey, Camera is actually deprecated. You should really be using Camera 2. But when I tried to use Camera 2, it was just simply too hard. It was like 1,000 lines of code to just get something very basic onto the screen. So what do we do? So at last year's Google I/O, we announced CameraX, and it's meant to be doing three things. The first one is to make it easy to use, just like Camera 1. The second is we want to improve on the device compatibility, and the API have been updated a little since I/O last year, so I'll try to run through some of those basic steps with you. And when you're using CameraX, there are three different use cases that we call them, that you can, or three modes that you can use them on. The first one is preview, second one is image capture, and the third one is image analysis. And of course, that's the one that, as machine learning practitioners, that's the one that you'll probably be most interested in. So we will focus on image analysis. To use this, you can basically, again, a bunch of Gradle import on your builder Gradle file. It is a beta at the moment, but and what it means, it is actually ready for production, and the APIs are frozen, and there are 3 steps to get it working with image analysis. So first, you can, we're creating the image analysis use case. You can define the target resolution. Just beware that the size is actually not guaranteed. So it will try to choose the closest one possible. So you might still need to do some resizing after you've got the image from CameraX, just so that you're aware. And then the second thing that it does is on this particular page is that it can also define what we call the image capture strategy. So with image analysis, you have 2 different modes. So one is to analyze every single frame that comes through, but quite often what you actually want is just the latest frame. So let's say you have a use case where the camera capture frame number 1 and your algorithm is processing it. In the meantime, 3 frames went by. You probably just want to get to the 4th frame instead of processing frame number 2, frame number 3, and then frame number 4. So by just specifying image analysis strategy, keep only latest, you can do this right away, and this is pretty easy to do. And then next, we'll add the analyzer. And here, as you can see, this is where basically you put your ML code. And one common mistake that we see developer do is that they put the image close immediately after the code. And this is fine if your code is executed asynchronously. However, for some of the APIs, so for example, if you're using this for MLKit, actually what it does is it kick off an asynchronous job to do the analysis. And what you should do is, instead of putting these dot close methods right at the end of the image analyzer, you put it under the a method called onComplete or add onComplete listener. So what it will do is it will try to analyze the image, and then after it finished analyzing the image, it will then close the image for you, and then the CameraX will feed you the next image. This is a fairly kind of common mistake, but hopefully you learn from my own. This is one of the first mistakes that I make using this. Finally, you can attach the image analysis lifecycle, and that's all you need to do. And another thing that I want to highlight is the new preview view. So in addition to the core kind of CameraX versions, we also have added this new camera view preview. And what it does is it enables you to just import the preview view into your layout and just add this, and you get a camera preview up. And the other thing that it does, and I'm not going to go through all the code that is related to actually attaching the preview, but instead I'll show you the code that enable you to do pinch to zoom. So previously, again, this is something that's really hard to do, but with CameraX, you can actually do this pretty easily. And this is what it looks like after you have done it. It's amazing, isn't it? So to find out more about CameraX, you can go to this link, g.co/CameraX. So we have went through design, we have went through finding a model, we have went through building a model, and we have went through integrating a model. So what is next? Actually, the next thing is back to ML design. So one of the things with building for machine learning is that it is an iterative process. And once you have finished the coding, you should actually test it more than ever. I know that a lot of you would already do this, with your normal Android app. But with machine learning, this is even more important to see if it works. And another thing is there are very kind of interesting problem that you need to fine-tune, or parameters that you should fine-tune related to machine learning that may not be something that is commonplace in traditional programming. And one of the things I want to highlight is this balance between precision and recall. And this is something that the People Plus AI guidebook that I talked about earlier actually covers. And so let's go through a problem, and let's illustrate this with an actual example. So I'm sure that a lot of you have heard about the Android application called Read Aloud that is from Google, where we try to improve the literacy around the world by helping children to learn how to read, and the phone will determine whether they have read it correctly or not. So what is precision and what is recall, and how does it and how does it actually manifest itself in this particular app? So with precision, what we are saying is we are biasing towards getting less false positives. But what this will also means is we will miss some true positives. In the read along app, what this will mean is that by having high precision, it will mean that some correct pronunciation will be marked as incorrect. So a child will have read a passage correctly, and the read along app will say, nope, that was wrong. So that will be optimizing for high precision. Another way is what we call optimizing for high recall. In this case, we will allow more false positives. And for this particular app, what it will mean is even if the child have pronounced something incorrect, we'll mark it as correct. And so this is the actual balance that you need to get. Is like, should I have high precision or high recall? And so which one did the read along app actually choose? They actually choose the high recall stance. Because if you put yourself into the shoe of the child, or put yourself into the shoe of a teacher, what you want to do is to be that bit more forgiving and that bit more encouraging to the child, rather than saying that, hey, you have to pronounce it exactly like this or exactly like that. So this is something that may vary depends on the use case, and this is something that is perhaps new. If for me at least, when I come from the traditional programming realm, where it is either correct or not correct. In this case, is a range, and you can choose where the balance lies. So to just wrap up, we just went through the journey of implementing on-device machine learning, from design to finding a model to building a model to implementing it, and then coming back to design and say, hey, how do we fine-tune the actual user experience based on some of the problems that are unique to machine learning. So to find out more, you can go to this link, goo.gle/mlwrap. So that's basically the wrap up blog post I've wrote, and in it there are all these links to all the various offerings that we have to help you along in the machine learning developer journey. So please do check it out, and if there's any problem, please just ping me on direct message. My DM is open on Twitter, and if you do have a question, please do basically put it in your first tweet. I get a lot of hi or hello. I would not be able to respond to those, but if you say, hey, I've came to your session on Android machine learning, I've got this question, I'll try my best to come back to you. So with that, that's the end of the presentation, and maybe some of the other people can come back, and then we can do a Q&A. I'm sure that there are some questions. Hello, you're back. Okay,
hey,
we have the slides now. It's just you and me.
Yeah, we have Anubhav here as well. So I'm just going to add Anubhav to the stream. So Shubham was having some issues with his internet. His internet was acting up. That's why he had to leave. So Anubhav is also one of the members of GDG Kolkata, and he's also present on the stream. And the funny thing is, he, along with one of his friends, Rimjim, so they authored a book on deep learning and Flutter. Not Android though, but Flutter. So their book was recently published, and I just wanted to throw that on the table. So yeah, you might want to give it a look. So yeah.
That's okay. We like Flutter too. This is anything that's good for a mobile developer is good for us.
Yeah, so we do not have any questions in the live comments, but folks, if you have any questions, you can ask it, or if you want to ask it on Twitter, that's also fine. The Twitter link is on the screen. So we'll just wait for a minute, and then we'll finally call it a day off. Does that sound good, Hui?
Yeah, that sounds great. Do you have any questions?
As of now, no. Although being an ardent on-device machine learning enthusiast, I'll have many as I keep working towards it in the coming days. So yeah, I'm working on an interesting project with Margaret right now, and you will hear from us very soon.
Yay! Hello. We have video.
Yeah. Hey, Hui. That was a great session. Thanks a lot.
Thank you. Yeah, and a lot more great things to come as well. So I'm sure a lot of you have seen MLKit had a basic call for public early access for both post detection as well as, I think it's entity extraction. So post detection is basically detecting where all your joins are. So we're hoping to provide that as an easy to use kind of Java/Kotlin API. And then on the other side, we have entity extraction, where you can give a bit of text and it'll say, hey, this is an address, or this is the time. And then you can kind of build different processes around that. Yeah, it's really exciting. Basically, everything is coming like every month. I need to update this stack. Like I have basically 12 versions of this stack, basically, because every month there is something new that's coming
along. There's also one integration with TensorFlow Lite and Firebase that came up last month, I guess. I believe that also going to be pretty useful for all the mobile developers out there.
Is that the Firebase hosting or auto?
Yeah, I mean the ease, the kind of ease that it offered to host a new custom TensorFlow Lite model on Firebase and do all the A/B testing and stuff like that.
Yeah.
So I found that pretty useful, and it's going to be helpful for a lot of Android folks out there, I hope.
Actually, this is a great question about kind of model hosting because, especially with some of the newer models, like I said, the 400,000 wine label classifier, that's 130 megabyte, and it's perhaps not something that you want to kind of include in your app itself. But there are various ways that you can serve a model. So with Firebase ML, if you are using the Firebase A/B testing and also maybe things like remote config, is a really good kind of thing to do to basically go, hey, let's A/B test not just the app itself, but maybe the model, etc. So that's one great way to do that. It does have a upper limit to the amount to the size of the model. I think is about 20 megabytes. So just beware. If you have something bigger, or if you're not using color Firebase for your A/B testing, actually I've just tested last week, so this is hot off the press. That with Google Play Services, we have something called dynamic asset delivery. So this is originally built for games. So it's like, hey, the next level is a gigabyte large. So you can kind of go there and or their code to basically download the next level in your game. But what I found is when I use that to download TF Lite kind of model, that also works. So you can now essentially either put the functionality into a separate module and say, hey, upload a module, or if you just want to put the TF Lite model itself into an asset pack, you can actually do that with the Google Play Services. And I think depending on when you want to download it, depending on kind of install time or dynamic, the size of that is, I think, up to a gigabyte. So I'm sure that it's, well, at least for now, is things will always get bigger, but at least for now, that completely satisfies my need for testing out a lot of models.
Yeah, I mean, absolutely. I haven't although tried the integration out yet, but yeah, we have got a project on the working group that will use it eventually. So I'm looking forward to that. Meanwhile, we have got a question from George, the guy who did the real-time style transfer thing. I
yeah.
hope you remember him. Yeah. So George is asking, hey Hoi, do you encourage quitting interpreter and use ML binding to every use case?
So I think for ML binding, if your particular use case is supported, then I will encourage you to use it simply because of the ease of use, and you don't need to do a lot of the fine tuning. But if you are kind of experimenting, or if you are kind of building for a use case that is not at the moment supported by ML binding, so for example, object detection. So not just classifying the entire picture, but actually telling you, hey, from which coordinate to which coordinate this particular object lives. That's at the moment not supported by ML binding. So I'm afraid in those cases you have no choice but to go back to the interpreter. Also at the moment not supported is NLP, so natural language processing. So again, you have no choice but to go to the interpreter. However, without giving away too much, that is something that we're looking into. So stay tuned for kind of more in the coming months.
Yeah, as far as I know, segmentation is also on its way. Image segmentation is also not supported via model binding as of yet.
Okay, you can say that, but I'm from Google, so I can't say anything.
Okay. We'll see. But yeah, I'm definitely looking forward to that one as well, because we just finished populating an image segmentation model with metadata. So yeah, I cannot wait to get my with model binding with that one. So yeah, I guess we do not have any more questions. And thank you so much, Roy, for taking the session once again. And we really are looking forward to hosting you for next time.
Thank you so much. It's really great to be here, and have a great weekend, everyone. Stay safe.
Yep. You too. Bye, Roy.
Bye.
Thanks for joining in.